Good morning, everybody. Welcome to the CSC 434 Socket Project Milestone presentation for Socket Group 82. I'm Srivatsav Erramilli, and I am in the group along with Rithwika Annamaneedu. And we are here. I'm here to demonstrate the Socket Project Milestone for you guys. First of all, I'll start with the DHT manager.py. This this Python file is used by the server or DHT manager node of the DHT network. It uses socket programming, threading for concurrent connections with the clients and servers, and it starts off with binding the socket with the server IP address and the server port. Our ports are available from 42,000 to 42,499, and it has the listen method, which listens for any incoming packets from any of the clients, which it peers. And right now the implemented methods are for the DHT complete and the register command and the setup DHT command. The register method recognizes the register command from the peer and attempt to register them into the DHT network. And if the peer already exists, or if the M port or P port is already used, it rejects the registration, or else it sends a success message to the peer. And for the setup.dht, once peer sets a sends a command for the setup DHT, the server tries to make the peer the leader and see if there's any other DHT that's already existing, and if there's no DHT existing, it and if the required amount of peers do exist, the server sends a success message to the peer and waits until the peer sends back a DHT complete message, which means that a DHT table has been fully formed. And here it recognizes the DHT for complete command, and those are the methods that are available in DHT manager. As for DHT peer, it implements the socket threading, and since it has to read from the CSV details 1950 CSV file, it implements the CSV module and the JSON module for better sending data through the network. It has two threads. Basically has three threads. One for which listens to the manager port, any incoming packets from the manager. One that listens for any incoming packets from the peers itself. Another that goes on with the program by registering it and setting up a DHT. It also the method for setting up ID, populating the DHT, searching for the next prime number, storing the data in the DHT in the local hash table, or sending it to the next the right neighbor in order to find the right identifier to store the data in the hash table, and it prints the configuration. And our project is also in GitHub, and with the 5 commits and each commit improving the code better and better, making better and better. And I want to show you the implementation of and the working of our Socket milestone project. And here in Cloud Lab, there are 4 nodes. Node 0 is what we're going to use as a server. Node 1 is what we're going to use as the leader for the DHT, and Node 2 and Node 3 are the peers. As you can see, the DHT manager.py is already in the Node 0. We're going to start the server by compiling and interpreting it. But Python doesn't need any compiler. It just automatically interprets the code and starts running it. And as you can see, the manager is up and running on port 42,000. We're going to start initializing the pairs, and here as soon as we initialize a pair, it automatically registers itself with the manager. As you can see, it sends a message. The node2 pair sends a message to the manager, which is node0, asking it for the register command. As you can see, the register command over here is the p2's IP address, p2's M port, and p port. And we do the same thing here for node3 pair. We call dht pair.py, which registers itself into the into a DHT network and sends a DHT manager the register command. And as you can see, all of them are waiting for any incoming packets from the peers or the managers so that they can perform additional functions. Even a node 0, even the manager is waiting. Here now for the node 1, we're going to uh, initialize the pair. And since this is the leader, it also starts setting up the DHT by after as soon as we initialize it. And as soon as we press enter over here, as you can see, the pair successfully first registers with the manager. And the breakpoint 1 and 2 that we have our group has created in order for better debugging information where the code is was not running before. And over here we see the peer, so the peer 1 first register itself to the manager. All the three pairs are connected to fully registered to the manager, and the pair sends a setup DHT command to the manager over here, and with the size 3 and the data set of 1950. And as soon as we do that, so here it's in the setup DHT command. It it waits for a response from the manager, and when it's success, and the manager responds with the required data set. It takes the data set and says the ID, ring size, and right neighbor of itself, and then passes the set ID command to the right neighbor of its pair, which is what it's doing over here. Yeah, identifier 0, ring size 3, and if we go to 2 over here, as you can see, the node 2 pair received a set ID command from node 1, telling it to set its identifier to 1 and the ring size to 3. And the node 3 pair received a set ID command from node 2, telling it to set its identifier to 2. And then after setting up the ring, the node 1 starts populating the DHT in each and every node in the pair, and it sends all this data, as you can see, to store different data sets, store 8, 401, and all this required data sets. And as you can see, some of the data is stored successfully in the hash table of P2. And if P2 is not the right identifier for the hash for the position function, it sends it to node 3, where it checks and then it stores itself successfully. And as you can see, the number of records in the local hash table of peer 3 is 56, of peer 2 is 59, and of peer 1 is 58. And after completing all this, peer 1 sends DHT complete command to the manager, and this successfully completes setting up the DHT. Thank you.